Okay, good evening. It's now 6:35. Let's start today's lecture. So today we'll be covering object-oriented programming. Okay, but first we'll do some revision of what we did last week. So this is the last topic, right, of that we were covering. So things like this, there are other advanced topics which are outside our syllabus. Okay, so this topic will span 3 weeks. 1 week, one topic. So today is week 10, 11, and 12. Okay, so we come to here. So 10, 11, and 12. So today we'll introduce OOP. Next week we'll talk about inheritance and then polymorphism. All right, then the revision and then practical exam 2 will be here. And reading week exam will be on 27 April. I think it's a Wednesday. Same date as last year, but different day, I think. Okay, so last week we looked at recursive structures. Right, so we look at two types of recursive structure. One is a linked list, where each node can link to at most one other node, right? And then we extend it to a tree, where each linked node can link to multiple nodes, right? So in this sense, isn't a linked list a kind of a tree? Yeah, it's a tree where each node can link to one, right? So a tree, a linked list is a subset, okay, of a tree in terms of definition. So when you have a recursive structure, right, how do you iterate now? Okay, going through a recursive structure. So you can do it with iteration, going down a linked list. For example, to count the number of nodes in the linked list or number of items, right? So the number of nodes of a linked list, you pass in the first node. So this will be the first node. Okay, maybe this is the root node or the head or whichever the first node. So count is 1 because there's one node, right? There's one node, count is 1. And then you go to node.next. Okay, visit the next person. Okay. If there's someone to visit, okay, then you can do a node.next, where you go visit the next person. Okay, like this, visit the next person. Then you add your count. Okay, you continue doing so until you reach here. Your node.next is now, right? Then this loop, you will exit the loop. Okay, you come here and then you return the count. Okay, so that's basically how you iterate through a recursive structure. Right? You can do that because inside this loop, you are going through all the different nodes, and all of them are self-similar. Okay, they have the same exact structure. Okay, for trees, now for tree, it is the problem with tree is that each node now has more than one children, like possibly more than one children. You cannot write a loop to say go to next node, because if you go to this node, you must remember to come back and go to this node. Right, so for tree, it is harder to do with iteration. It's not impossible, but it requires more slightly more complexity. Okay, but if you use recursion, it is pretty easy, because you can write a loop to iterate through all your children, right? You can write a loop to do that, and as you iterate through your children, you recursively call the function on each. Like you recursively call the whatever function you want to do. Okay, so. And then the key, so the count number of nodes in the tree is basically the number of nodes of this big tree is 1 plus the nodes of each children. Right? So it's 1 plus. So you ask this child, how many children do you have? So this 2 will say 1, 2, 3, 4, 5, plus myself 6. Right? So how many members are there in your family? 6. So this then you ask your next child, how many members? This one will say 1, 2, 3. So he'll tell you 4. Okay, so you basically add them all together, you plus 1. So in total, there are 11 members in my family, in my tree. Okay, so how do we write the code? Basically, you can write a for. You need to use basically some kind of looping inside the recursion. Basically, you need to loop through all your children, right? In this case, your tree can have any number of children. So you loop through each of the children, and then you call num nodes here. Okay? Number of nodes of the children. Now here I use a pointer. I think previously I used a reference. Okay, so why here I use pointer and not reference? Will this work with reference? Will this work if this reference? Do you think this will work? This code will work? Who say yes or no? need to modify. Yeah, what do you need to modify? So if I just make this a reference, okay, obviously this will not be pointer lah, right? Then this will be dot lah, okay? So in this code here, it will fail. Where will it fail? It will fail if I'm at the node, right? So suppose this is node. Okay. Actually, no, actually here, this will fail because node has no children. Right? Node has no, where's my pen? My pen disappeared. Okay. This will fail. Where's my animation? Is here. For tree in node.children, node.children is empty. Actually, this will still work. Okay. This will still work because node.children is empty. I have no children. Right? If I have no children, then this for loop will not run. So I'm using this basically this ranged for loop. Okay, we should not run if there's no children. Okay, so I'll just be 1 plus count. So count will be 0. So it'll still work. Okay, by modifying. Okay, so this code is safe. Okay, if you modify this to a reference. How about counting number of leaves in the tree? Well, basically, number of leaves in a tree. Basically, you're counting how many nodes are there with no children. So 1, 2, 3, 4, 5, right? Okay. So here, basically, if your children size is 0, you return 1. Okay. Otherwise, you iterate through. Okay. You iterate through all your children and ask them how many leaves do you have, right? So the total is how many leaves of all your children. So this children will say I have 1, 2, 4 leaves. This child will say I have 2 leaves. So altogether I have 6 leaves. Okay. So here use pointer or reference is still no issue. Okay. Now how about this part? Okay, so if you count the height of a tree, so this one is no longer arbitrary tree of children. This is a binary search tree. Okay, so binary search tree, we did not use a vector to contain the children. We have a left and right. Okay, so in this left and right, now how does this work? What's the height tree? So the height of this tree is the height of the max height of each of my children. So you ask this child, how tall are you? How tall are you? Okay, so the max of the height of each children plus 1. So this one will tell me I am height 3. This child will tell me I'm height 4. So one is height 3, one is height 2. So I will be height 4. Or in other words, height is like how many generations. If you think of it as a family tree, right? So how many generations are there from you? Okay, so basically you ask all your children, right? How many generation does your family have? Do you have? Right? So you take the max. So this child has 3rd generation, so I'm plus 1, I'm 4th. Okay, so this basically how recursion works. Right? Recursion is basically asking the same problem to your children. Okay, now in this example, if you put ampersand here you have a problem if you use reference, right? Because suppose you are here. Okay, this code says I'm here, right? So I'm not now, but I return 1 plus height of my left and right. The problem is left and right is now, right? You cannot pass now into a reference. Reference cannot be now. Then you will have an error here. You cannot pass now into a reference, right? But pointer, you can pass now. So here we use this as pointer and check for now, basically to make the code a bit cleaner, more succinct. Otherwise, it's possible to still use reference, but you have to check. Make sure you have a left child, make sure you have a right child. If you have no left or right child, then it's just 1 plus 0 in a sense, right? So you need to check left, check right, and then add plus 1. Okay, so here we don't check left, check, we just straight away recursively call to nobody, to now. So this one will end up being now. So we check not equal now. That's why we use pointer. Okay, so the key of using pointer mean you cannot use reference if this input will become now. Y part of the pointer instead of reference. Okay. So here let us talk briefly about this thing called function overloading. I think we might have talked about it in 101 before. So in C++ or even C, functions are identified by the name of the function and also by the type of the parameters. Okay, so in C++, you get multiple versions of a function, okay, of the same name, but different signature in terms of the number of inputs and a type. And so you can differentiate. Basically, the compiler can see what you are calling, look at a type, and then match which function that is. Okay. So for example, say I have a function called integer max. Okay. Takes in an int and an int, okay, and does this. I can have another function called max that takes in 3 integers. All right. Notice that inside here it calls the max with that takes 2 integers. Right. So here I have a max that takes 2 doubles. For max that takes 2 doubles, if their difference is close enough, I return A. Okay. Because with a doubles, there's certain imprecision. So here I think the imprecision is 5 decimal places lah. So if they are within 5 decimal places of each other, I will say one is bigger than the other. All right. So this max function is overloaded. This is what we call overloaded. So if I call max xy, this is integer, the compiler will match this call to this, okay, matching based on the name and the int. This one has 3 integers, so when I call this, the compiler will match this to this. Okay, this one has 2 doubles, then it will match. Right. What happens if one is a double, one is an int? If one is double, one is an int, in a way, I think you might get a warning. Again, depends on compiler. You may get a warning, or a compiler may upgrade one of your int to a double. You'll relax the restriction. Then you'll call the double one. Okay. So you may get a warning or an error, again, depending on your compiler. Okay? Because as we know in C++, there's this implicit conversion. So your int may get converted into double. Why this don't use template? I'm just demonstrating to you overloading. Okay, so here I have 2 variables. Here I have 3. Right? Then template cannot use for 2 or 3. Okay, so here don't use template also because I'm doing different things, right? If both are integer, I can simply return this. If this is double, I'm doing something different. So it's not template means I can take anything I want, then I do the same thing, right? So here we don't have template because if it's a double, the way I compare is different. I cannot just compare A and B, right? I want to have certain threshold here. Right? So here also can use template because int and double, I'm doing 2 different things. Okay, so here I use a function overloading. Okay, for this. But here I cast to int. So the thing about function overloading, I think the return type have to be the same. And the return type, no choice, have to be the same. It cannot be different, because if you choose to call the function, then the result different, then a bit of a problem. Right. Okay. Okay, so that is a function overloading. Now, why we revise this function overloading is because we will see this again in OOP. Okay. So what is a OOP? Right? So let us recall what we have learned before as well. So we learned abstract data type some weeks ago, right? And we know abstract data type is basically the data, okay, of datum, which is singular, the data struct, and operations. Okay. So in our ADT, our data and the function are loosely coupled. Right? There's no strict coupling that says, oh, this data I must use this function. No, we sort of have certain functions to work on our data. Okay? There's no contract here. Okay. So what's the problem here is that there are a few issues, a few problems we need to overcome here. Okay, or there can be some problems. So the scope of the function is not coupled with the struct, right? So translate point P double X double Y equals this P by X. Okay. So the translate function is in the global scope, right? Is in a global function scope. So there's no control over who can manipulate this point in a sense, right? Okay, so any point I have, anywhere I can call translate function. Then what if I have point P, but I define it differently? So this one is probably the Cartesian form, right? XY coordinate form. What if I have point defined in a polar form? Because of function abstraction, I don't really know what point is defined internally. Right? I could call point, but internally I don't have XY, I have polar form, right? Angle and theta and distance and radius. Okay. So the problem is these two are not compatible, right? Because this point no longer have dot X or dot Y anymore. Okay, so do you call a new struct point P for point polar or and point C for point Cartesian? Can get quite confusing. Okay, so let's illustrate this with another example. Let us use bank account. Okay, so we will create a bank account ADT. Right. So what does a bank account need? Let's just assume two basic information: a bank account number, which is just an integer, right, and a balance, which is just a double amount of money you have in your bank account. Okay, and what operations we have? We can withdraw, we can deposit into our bank account. So a simple bank account struct would just have the account number and balance, right? Here we use the make account constructor, which returns a new bank account. Okay, so we use this form which returns a copy of a bank account. So we create an account using account number and the balance. Okay, so here we use the C11 syntax on the initializer string and initializer brace, okay, to return this. Okay, then to deposit money, basically take in account as reference and some amount, and you add amount in your balance. Okay, the very basic. And withdrawing. So when you withdraw, our bank account cannot leave negative balance, right? We don't want to allow people to withdraw more than they have. So before you withdraw, you check whether balance more than account amount. If it more than equal, if it is, then you deduct and you return true. So this one returns Boolean. So the Boolean returns whether successful or not. Okay. Okay, how to use the account? So let's make my account 1234. $1,000 inside. Deposit $1,000 into my account. I have $2,000 inside. I withdraw 500, I should have 1,500. So if I try to withdraw 2,000, this should fail, right? This should return me false. And my account should have 1,500 left. You can go and try this simple code out. If you view the balance, it should show 1,500. Right? All convinced this is correct. Now, what's the problem with this account? The struct my account, the bank account, it is public, right? I mean, anyone can access. So there's nothing stopping me from going and say, oh, my account balance equal to some $1 billion, $100 billion. Okay, and nothing stopping me from doing this. Okay, so that is not what we want, right? So anyhow I put money into my bank account. So that's the issue with this data, right? Is how do you even make a password? You cannot, right? So the my account balance is accessible as long as you have a struct called my account. I can just change the value. So this is where object programming comes in. Okay, so in OP is a paradigm. Okay, it is a programming. Sometimes you hear object-oriented paradigm. Okay, basically it is the model of the language. I have paradigm. Now, what's the model of a language? Basically, a language deals with how information is processed and organized. That is a way of thinking. So there are a few popular programming paradigm. Okay, so C is an imperative paradigm. As of now, we have only used the imperative part of C++. It's C++, so C++ is an extension of C. We've only dealt with the imperative thing. So imperative would just be as a state, memory, and then you call functions. You call line after line, you call functions, we manipulate a state. And so this is what we have been doing so far. Then we will go into object-oriented paradigm. Okay, this is what we will learn. So Java is fully OOP and C# as well. Okay. There's also functional paradigm like scalar Haskell scheme, JavaScript, where the programs are made of functions like math, and functions apply on other functions. Okay, there is no actual memory data like a heap storage kind of thing where you create new data. Don't have. You take data and you pass through functions, and functions return data. So that is the functional way of doing this. So it's really like math. Okay. And then there's declarative, which is prolog. Prolog is basically you write certain rules. Okay. A bunch of rules you write already, then you say execute the rules, evaluate the rules, and then the result come out. Okay, so it's quite magical. But anyway, there are other versions of paradigm out there. Okay, so when you talk about programming, we are only learning one particular paradigm, which is imperative OOP. Okay, this paradigm. Okay, so in the world of programming, there are many other ways of programming out there. Okay. So what is this procedural versus OOP? So what we're looking at is mostly imperative, which is also called procedural. Okay, so in procedural, so this part here is procedural, right? Okay, so this part here procedural. In procedural, program is viewed as a collection of functions, which is what C++ is, right? A bunch of functions there with the main function as an entry point. Okay, so your data and functions are separated. Right, you can create variables, you create structs, you can new structs, right, to create in a heap and pass them into functions. So everything is public here. Okay. So what's so good about this is that it very closely resembles the execution model of hardware. A lot of times when we deal with C++, we talk about, oh, how is it like in memory, right? And when you pass it around, how do you pass point memory? So in a sense, it's very close to the way the actual hardware execute your instructions. Okay, so there's typically less overhead. Okay, but the problem with this is that once you have a lot of functions, you can imagine a big program, lots of functions, lots of data everywhere, can be quite hard to maintain. Okay, so in OOP, instead of viewing the program as a bunch of functions, you view them as a collection of objects. And what objects, we'll look at it later. So basically, objects are functions and data. Okay, so functions are generally public, data are generally private. Okay, we will see this next slide. Okay, so why this is the con is that this represents models and relation in real life rather than how it is actually executed on the hardware. Therefore, it has slightly more overhead. So back to the argument of Java is slower than C++, mostly this, right? Because Java, everything must be an object. So there's slightly more overhead. Okay. And but the nice thing is that this is easy for us humans to understand, and we can use inheritance and polymorphism to do customization. So easy for human to understand, harder, more complex for the machine to execute. Right, the other way around, easy for machine to execute, hard for human to understand. Right, we don't even program in assembly. Assembly is completely hard, right? But very fast. It's exactly what the instruction that the computer execute. Right, so there's this a spectrum of things. Okay, so OP has three main concepts. Okay, so we'll take three weeks, okay, to go through each of these concepts. So this week we look at encapsulation. Then next week we look at inheritance. Then another week we look at polymorphism. Okay, so three different concepts to cover. So we spread it out over 3 weeks. Okay, so what's encapsulation? So going back to compare procedural model with OP model. So in procedural model, we mentioned before the data, which are structs, and the processes, which are functions, are separate entities. Right? So here, my bank account is a struct. Then I have certain functions here. Okay, so they are separate entities, and there's sort of an informal contract between them, right? That I will pass a bank account into deposit. So the function here makes certain assumptions, or they believe that the bank account has these properties. If not, the compilation will fail. Okay, so they have this a kind of a relationship. Okay. Now in the OP, what happens is that instead of data and functions being separated, what you have is you have this thing called an object. Okay? And in the object, basically the data is hidden inside the object and encapsulated by functions. Okay, so there's typically no direct access to data. So data is private. So your account number and balance are private information. How do you get the data? Well, go through the functions. So access to the data now has to go through the functions. So you can now see I cannot arbitrarily go and change my data. I must go through the functions, right? And the functions, I can put certain code to restrict certain modification or certain access. Okay, so let us take a look at how we write bank account in OP using classes instead of using a struct. Well, the structure looks very similar, okay, to a struct. Okay, basically instead of struct, I put class. Okay, so in a class, the properties I have typically by default are private. Okay, like what Peng said, same as Java. Okay, you have public and private. Okay, so private, under private here, so this are the properties. Basically, it's the same as your struct properties. Right, you declare all these properties just like a struct. Okay, in addition to properties, you can also declare functions. Now, functions you probably want to make public. Otherwise, not very useful, right? Functions are private, no one can access. So you make public. Okay, when your functions are public, then basically you can take in terms of the withdraw function next amount. Here, I can access balance. So this balance here, basically by default refers to this. Okay, so this is within the scope, right? So the functions inside my class. So notice the class has a bracket here and close bracket with semicolon. Same as struct. The functions inside here, all these are within scope. So this balance here refers to this balance, right? This amount here comes in from this amount. Okay, so if I were to withdraw amount, basically check whether the balance is less than amount. If it is, then return false, cannot withdraw. Otherwise, let's modify the balance and return true. Okay, deposit, very simply, just add the balance out. I don't have to check, add the balance out. Okay, what does virtual mean? We will talk about that when we talk about it 2 weeks later in polymorphism. Okay, for now, we just learn, let's put virtual. Okay, so okay, virtual is a C++ thing. In other programming languages like Java, all functions are by default virtual. There's no non-virtual. So C++ have virtual, have non-virtual. But this is a complex thing that only have in C++. Why? Again, optimization, give finer control to the programmer. The idea of having non-virtual is not simple. I will teach, okay, about it, but it's not tested. So we'll cover this when we talk about it 3 weeks later, 2 weeks later lah. Okay, so for now, just every function inside a class, put virtual. Okay, let's put. If you don't put virtual, the behavior is different. Right? But we will not go into depth about that alternate behavior. So make sure you just put virtual. Okay. So someone asked whether it's best practice to put private variable like underscore. These days, not likely actually, because these days everyone use some professional IDE, right? Where you put your cursor over the balance like this, right? Then it will tell you a lot of information. Okay, so these days not so much some convention. Okay, but I mean I put here because we have no IDE lah. Okay, so is it best practice? Again, depend on the project you're working on. Okay, they may have certain format, okay, or practices to adhere to. Okay, so these are attribute or properties, and just like struct, we can put default property value. Okay, these are the functions. Okay, so new terminology. Functions inside a class are called methods. Okay, don't ask me why called method lah. Just the terminology. Okay, so variables inside a class are called properties, right? Or attributes. Just like the struct. Okay, sometimes we call it attribute, sometimes we call it property. Okay, but they're just basically variables in a class. So functions in a class are called methods, and this is the new term. Okay, but we're not dogmatic about it. Like if you use functions in the class, it's fine. We understand can already. Okay, so the methods in the class can access all the attributes, right? Because it's in the same scope under the same class, right? So don't care private or public, we are in the same scope. Okay, so we can access. So private means only in the same scope. Okay, later we will talk about this. The difference. Accessibility. Okay, so let's compare the old procedural way struct with the class. Okay, so if you see here and here, the same, right? They're just properties of each other. Okay, but in our struct, that's the end. Okay, here I have I have three functions. They are floating outside the struct. Okay? Whereas in the class, the functions withdraw and deposit are within. Okay, within the class. Okay, so the properties I feel here, the accessors and getters are here as well. Okay, so slight difference. Okay, but now the properties now are private. Okay, so let's talk about accessibilities. Okay, so for C++, okay, so different programming language will have different accessibility types. Okay, for example, Python have no accessibility. Everything in Python is public. Okay, so Python, even if you declare a class and put properties, it's all public and there's no private in Python. Java has, I think, 4 types of accessibility. Okay, so different languages have different accessibility. For C++, we have 3. And most of the accessibility are generally about the same. So you have public, okay, which we all know everyone access, open to all. Okay, public access. Private, only in the same class you can access. And so only your methods, right, your personal functions in your class can access. So it's very private. So how about in between? So in between, there's this thing called protected. Okay, so protected, same class or subclass. Now, what is subclass? Subclass, we'll talk about it next week because subclass talk about inheritance. Inheritance. Okay, so basically it's family lah. Okay, so there's inheritance. So protected is only for inheritance. This week we don't talk about inheritance. Next week then we talk about inheritance. Okay, so these are the three levels of accessibility for C++. Right. So looking at bank class, now how do we create our bank class? So bank account BA, then I deposit 500, I withdraw this. Okay, so I declare a bank class. It's just the same way as we declare a struct. Okay? Create a bank class, update the things using the mutator and setter. So now the function, instead of the function being deposit, take in a bank class, now you have bank account dot deposit. Now this is very similar to your vectors and strings, right? Or map, or which you use the dot because now you're using the functions related to that class. Okay, so here we use the dot, which is basically how you access properties in the first place, right? Just like struct. Here, you will try to do a BA balance. Actually, this is a compile error. In fact, this whole thing will not run. Compiler will say, you have this line. I cannot compile into instructions because balance is private. So the compiler will complain. Compiler will say error. Okay, I cannot translate this into instructions. Okay, so I can go further. So suppose you fix the error. Okay, suppose you delete this line. You delete this line and you run this. The question now is, can you access this? No, you cannot access this because bank account is also private. Okay, so you cannot access these properties. So how to access the details? Right? Suppose you want to figure out what's the balance, right? How much balance you have. So what we need is we need to have accessor or selector methods. Okay? Previously in struct, we don't need. In struct, you can always access, but with ADT, we need, right? Some of you realize like a point, you must use X off or Y off in your training now, because you don't know how the point is designed. So same thing here, we use accessors and selectors. So we need to get account number, get balance method. So that's right. Okay, so here we have public mutators, withdraw and deposit. We have accessors. Okay, get account number, return account number, get balance, return balance. Very, very simple, right? Just get and return. Okay, so one thing to realize is now your account number, you realize there are no mutators that modify your account number. Right? So the only mutators I have is withdraw, which basically change balance, deposit, change balance. There's no mutator for account number. So this one becomes a read-only property. There is no way to change it, which makes sense. You don't want to be changing account number, right? Create account number is there, it's permanent until you delete the account. I mean, even if you delete your account, the account number is not recycled. People don't recycle account numbers. Okay, so this becomes a read-only property. All right. Now the question is, if account number is a read-only property, obviously there's no default value, right? Because there's no default account number. Even if you want a default account number, there must be a way to set it. But if there's a way to set it, then it no longer becomes read-only, right? If you put a set account number, right? So you say set account number, then it defeats the purpose, right? We want our account number to be read-only. Okay? So there's no default value. Unlike balance, balance default is 0. Every time you create a new bank account, default is 0. Okay? And balance, you can add money and deposit. Right? So the question now, how do we initialize this without using a setter or mutator? Okay? And that comes in this thing. Okay, so comparing again to struct. Okay, you realize just now, you might have realized just now when I talk about, there's mutators here. Okay, we have properties here. I left out this thing, right? So in our procedural way, we have this constructor, right? The constructor. Okay, so where is the constructor here? I haven't implemented yet. Okay, so now we need to write a constructor, okay, for our bank account class. Okay, so each class will have one or more constructor. You have more than one constructor. Okay, so this is a special method. It is called automatically. You don't need to explicitly go and call make bank account. Okay, when you create the bank account, the constructor is called. Then you might ask me, how come my code earlier on worked when I had no constructor? Because C++ automatically provide a default constructor. Basically, it's a constructor that does nothing. It takes no input, it does nothing. So if you have that, then you can just create it will just create a class for you, right? With all the properties. Again, those that you have no default value, it will be whatever random value is in memory at the time. Okay? Because you did not initialize. Okay. So obviously, most of the time, the default constructor is insufficient for what we need. Right? We need to give some initializing values. Okay. So we must write our own non-default constructor. Okay, they can take in parameters. Okay. And we can have multiple different constructors. In a sense, it is overloading the constructor using different signature, in the signature being the number of inputs and type of input. Okay. Okay. So let's use the bank account class. So this one, we use the default constructor, right? So if we declare an instance like this, default constructor is called. Or default constructor is called, we use default values. Okay. So here we want to write our own customized constructor. So what it looks like is just this. Public. Okay, I mean, it has to be public. If it's private, then nobody can call from outside. Okay, so it's public. Okay. Then constructors, notice something interesting about this function. it has no return type. Normally functions in the front has the return type, but constructors have no return type. And the other thing is the constructor have the same name as the class. Okay. Now, this is C++ way of defining constructors. Python have a different way of doing it. It's similar to Java. Java and C++ share similar construct. Other languages have different keywords for constructor. Like for Swift, the constructor is called init, init. Okay, so again, different language have different syntax. Okay, but generally the concepts are the same. Okay. So here, the account number, so here the constructor taking account number. Okay, in this case, we just set account number to account number, right? So, okay, and balance basically set to 0 because by default it's 0. Now, constructors are overloaded. So earlier on we talked about overloaded. So there are two constructors here. They are different because this one has 1 input, this one has 2 input. Okay, so depending on what you call, the compiler will call the different constructors. Okay, by depending on how many inputs you specify. So this is the one with this amount basically set the balance to the amount. Okay, so at first the balance will be 0, but this will be replaced. Okay, with the amount. So let us look at the implementation usage. Okay, so in my main, I can do bank account 1, 1, 2, 3, 4. So this will use the first constructor. So balance will just be by default 0. Okay. I can call the same constructor. So 1, 2, 3, 1, 2, 3, 5, 1000. So this is the bank account number, right? This is the balance that I have. So this will call the second constructor. Now, can I still use BA3? Now cannot already. Now, earlier on I could use, but now cannot, because once I provide a customized constructor, okay, there will be no more default constructor. Okay, so there will be no more automatic default constructor. The moment I define a constructor, then no more default constructor. But what if the constructor of no input is meaningful? But you may sometimes want to have a constructor of no input. Then you must go and define that. You define a constructor with no input. Okay, but basically, this is what this what is doing. This is a constructor with no input. Okay, if that is useful to you, then now you must explicitly define one. Okay, so no more automatically given for you. Okay, so running through our bank account class, remember we are building ADT, so we have constructors. Check. Okay, bank account class have constructors. Do we have accessors? Yes, we can have accessors. Do we have mutators? Yes, mutators. Check. Okay, so let me see whether is it a good time to take a break now. Okay, I guess we're gonna take a break now before we move into the instances. Okay, so we have talked about creating our bank account class. Right, so now it's 7:20. It's almost 1 hour, 45 minutes have passed. Okay, so we take a 10-minute break, and we will come back for another 40 minutes. Okay, so we'll take a 10-minute break now. We will come back. All methods with same name as a class will be constructed directly. Yes. Okay. Method with the same name is a constructor, and it cannot have a return type. Basically, because it returns the class. Okay. So you're not allowed to create a method with a different return type, the same name. The compiler will complain. Okay. So methods with the same name without a return value in front, they are the constructors. Okay, it means they are automatically called when you do instantiation here. So here we will talk about this instantiation after the break. Okay, so 7:19 we'll come back 7:29. Okay, and we'll go for another 40 minutes. Okay. Okay. Let me just close that video. I just randomly find some video on TED to watch. Okay. Okay. So let's come back to our lecture. Where the last two lecture upload. Okay, I'll go upload. Well, was that probably Zoom with the with the download last week. Okay, I'll go and fix that and upload the last two lectures. Okay. Okay. So today's one will not be processed so soon. So it takes a while to process the lectures. Okay. Okay, I should remind earlier that you have to done it during the break. Never mind, I will do it after the lecture. Okay. So next new terminology to learn today is this thing called instance. Or object. Sometimes you call it object. Or what's an instance? So an instance is like English or instance is something that come out. Okay, instance of of a of a idea, right? Of a thing. Okay, so when you create a bank account, so here we say BA1, okay, has this inputs. We are creating one bank account. So in memory, you have BA1 occupying some part in memory, just like your struct. Okay, you call BA2 will be another occupy another region in memory. So these two are what we call instances, which are entities. Okay, so in OP, you said they are instance of a class. In a sense, they are the actualization of the class. So a class, you think of it as some kind of like a template, a blueprint. I don't use the template, very confusing because you have template. A blueprint of properties and methods. So when you instantiate, or you construct an object, instantiate, okay, an instance of a class. So here, BA1 and BA2, they are different instances. So they contain different properties. I told two different bank accounts contain two different properties. So here, firstly, I can manipulate their balances, okay, separately. Okay. So in objects, basically, they are passed by value. Basically, they are being copied. Okay, the properties of the object are being copied over. Just like structs. Okay, so structs are passed by value. Objects or instances are also passed by value. So if you look here, let's say we have a procedural function, okay, called transfer. Transfer from bank account to a bank account, some amount. So from withdraw amount to deposit amount. What's wrong with this code? What's wrong here? What's wrong? What's wrong? It's passed by value, right? So if you don't pass by value, do you think from and to will be updated? No, right? Okay, they won't be updated because it is passed by value. So the right way is you must make them reference. Okay, just like our structs. Okay, so in this case, okay, we pass by struct. Well, it's recommended to pass all object by reference so you don't end up copying things. This is how we like to pass our vectors, pass our struct, right, as reference. Okay, so the problem with passing by reference is any modification to it will affect the actual object. Unless you put constant there. So you put constant there, then you're telling the function, yes, pass by reference, but don't modify the object. And the compiler, so the compiler will make sure that the object, okay, the contents will not be touched. Well, here we can update properly, but there's a logic error, right? What's the logic error? Logic error is you should, if your withdrawal fails, you should not deposit, right? I mean, okay, you deposit first or withdraw first, no difference. But the problem is if your withdrawal fails, you should not be able to deposit. You know, money appear from nowhere, right? Okay. So logic error is if your withdrawal is true, it passes, then you do a deposit. So you make sure you check for sufficient balance first. Okay, this is a logic thing. Okay, so you understand this code, right? So withdraw, if it's successful, you return true. Then you can go on and deposit. Like if it returns false, then you don't do the deposit. Okay. So this transfer function feels procedural, right? Because it is procedural. In a sense, it's outside any method, right? So it's outside any class. It's floating around in the global namespace. So it feels procedural. So let us fix it and make it a class method. Okay, method of bank account. So transfer basically is either transfer from or transfer to lah. So here we call it transfer from lah. Okay, so as a bank account, call it transfer will be from someone else. Okay, so here from if someone else balance is more than amount, then I minus the amount, then I increase my balance, right? So here's the thing. Because we are a method under bank account class, okay, we can access our private method balance, right? Right, we access the private sorry, not method, private property balance, even though it may appear that from is someone else. Okay, so this is a slightly confusing. So from may appear to be from outside, right? So you may think balance is private, I should not touch other people. But that's not what private means. Private just means because from is a bank account, which is me. Okay, so I know that bank account has a balance, so I can access this. Okay, so I can access the properties of other bank account instances. Okay, so that's what private means. It's not, it doesn't mean only your instance can access it. Okay, yeah. Private means all class instances of all class can access. Okay. In a way, it is because I have a bank account, so I know what properties you have. You have the same properties as me in a sense. Okay. So the from balance more than amount, then I deduct. Then I add to my balance. So I have this. Also, what is this? What is this? Okay. So this in C++, okay, it's a pointer. This is automatically created in any method to refer to the particular instance that is calling the method. So this is automatic. Okay. Java also have this. Swift will use self. Okay, so the name may change. Python, you must explicitly put a self input, like things like that. So this concept of referring to the instance itself, okay, is a common thing in object-oriented programs. Okay. So you can access all your own methods or attributes using this pointer. Okay. If there's no ambiguity, then you don't need to put this. So earlier on, we did not put this, right? We just simply underscore balance because there's only one scope, which is my own property. So there's no ambiguity. You can do not put this there. So technically here, I don't need to put this as well. Technically here, I don't put this. It will still work because this is from balance. This is it's only one scope of this, which is my own. Okay. But I put this here so that to highlight there was this thing called this. All right. So let's see what happens here. So to understand how this work is, so let's say we call so BA1 and BA2 are two instances, right? So this is the memory. Okay, this might be stacked memory. So basically you have account number, balance, account number, balance. So BA1 dot transfer. So BA1 is the instance. It's calling the method. Okay, this should be familiar because we have been playing with vector dot something, right? So on that vector, you operate. So here we are on BA1 operate. So when we are in the transfer function, so this is the memory stack of the transfer function, we have a special pointer called this. It will be created automatically. And the compiler will compile that automatically. So this will point to the instance, your instance. Okay. From, okay, from is not a pointer because I use reference. Okay, so from basically is same occupy same memory here. From, okay, maybe I should do pointer this here. Maybe next time I should put a arrow to this. Maybe that makes more sense. So it's not a pointer, it's a reference, the alias is a reference. Okay, amount by passed by copy will be 500. Okay, so what will this do? Where are we now? So it will transfer. It will transfer the 500 over lah. Right? You minus 500 from the balance and you add 500 to this balance. Okay, and because this is a pointer, that's why we use this arrow. This is pointer. Okay, so all clear about this special variable. This. Okay, and any questions on this? Here's the pointer. Now, we have talked about account class. Okay, so why point to BA1? I press wrong button. Why point to BA1? Because this is BA1 calling, right? BA1 dot transfer. So when BA1 dot transfer, this is now pointing to BA1. So it is a pointer to yourself. You can do more with this than just referring to your properties. You can pass this pointer into other things. It's just a pointer. Okay, so because BA1 is the caller, okay, the BA1 dot transfer. So this pointer refers to BA1. So this basically refers to the instance that activate the method, the instance that calls the method. Okay, so you think of a function, a method call, it's just like a function call lah. Okay, but in order to capture who is the instance that call it, they have this special pointer. Okay, other languages also have this thing. I think Java have this, Swift will have self, Python has self. Okay, so yes, you can call BA2 transfer BA2. So you will deduct BA 500 from yourself and deposit 500 to yourself. Right? So yeah. Okay, so definitely it will work. Okay, you just trace your function, it will work. Yeah. I mean, if there's any admin fee, then you incur admin fee. Okay. All right. So we have talked about constructors, we have access mutators. Now, last thing we're going to talk about is destructors. Okay. Got constructor, must have destructor. Okay. So what's this destructor thing? You realize in our when we did our recursive structure, right? We had do I have this example here? Yeah. We have an example here. Okay, so I go there. Okay, so what's this destructor for? Okay, a destructor is called when a class, okay, gets destroyed in a sense, right? It goes out of scope. Means the memory of the class. Okay, so out of scope is on the stack lah. Okay, so the stack gets cleared. Okay, the compiler will automatically go and call a destructor. Okay, destroy. I'm destroying you. In a sense, the memory you're using is being free, or you get deleted. Remember, I think last week we talked about you can new struct on a heap. You can delete the struct from the heap. Okay, so same thing. If you new a class on the heap, you can delete the class on the heap. Okay, so you should have a destructor if you allocated memory dynamically, or you request for system resource. This one we didn't really talk about, but because it was system resource, we did mention when you create a file, you must create a file pointer, right? When you're done, you must free it up. If you don't free it up, then no one else can use the file pointer anymore. Okay, so basically, this is a destructor. So every class only have one destructor. You cannot overload the destructor. Why? Because the destructor have no inputs, no return type. You're not allowed to pass any special thing in a destructor. So the compiler will just call the destructor. Okay, just like that. How to define it basically is like the constructor. Same name, only you put the tilde in front. Okay, again, if you don't have a destructor, then the default instructor is given, which does nothing. Okay, so that the compiler won't fail. Won't fail. Now, why do we need destructor? So you recall last week, was it last week or 2 weeks ago, right? Where we talked about QADT. Last week, right? We talked about link node. Okay. So actually there's a bug, in our QADT. There's a memory leak, right? Where is the memory leak? So suppose we're at main. Okay. Then we call full, right? So we go to full here. Okay. So we are inside the function full now. So full, we create a queue. So this is our queue, right? So our queue, when we create a queue of integer, basically it was a struct, right? Our queue was a struct. Okay. And the default value of struct is size is 0. Size is 0. Head was null. And tail was null, right? That was the default. So here I enqueue1 and queue2. So when you enqueue into your queue, this is procedural paradigm, right? What happened was they created link nodes in the heap memory. Okay, so when you enqueue1 and queue2, so we have 2 link nodes, right? In the heap memory, 1 and 2. So the head points to here, the tail points, right? So we have this in heap memory. Okay. Now, reach here, end of the line, right? I mean, function done. We return to main function. So whatever data we had here is now recycled. But we still have these 2 link nodes in our heap memory. We did not delete them. So memory has leaked, right? So what we talk about, memory leaking. So actually our queue implementation, we had a leaky memory. Okay, we did not clear the queue. Okay, so memory has leaked now, right? So all this is recycled, but this 2 heap memory now cannot be recovered ever. Okay, for the duration of your program. Obviously, when your program exits and quits, the operating system will recover all memory that it has set aside for your program. Right? But for the life of your program as it runs, these 2 memory will never be recovered in this sense. Okay. So like I said last week, if the program is a long-running program, slowly get lesser and lesser memory until it crash. Okay. So in a sense, object, now you have allocation, which is when you create. Okay, so when you are creating or new is being used, memory is allocated either on heap, okay, or if you use if you either on stack, okay, when it is a variable in the scope, or use new. Okay, in this case, constructor is called, and when it's alive, okay, you use it. When it's dying, it's going to be called a destructor. Okay, when it goes out of scope, or when delete is used. Okay, on the object pointer. When you new something, you get a pointer to the object. Okay, so you compute delete on the object pointer. Okay, so destructor will be called, and the memory occupied is deallocated. So the destructor is a time where it's given to you to go and clean up all the memory that you have used. Okay, so for example, let's take a look at this example. So this example shows you where the destructor and constructor is being called. And so let's see. Okay, where's my code? Okay, so test. Okay, test. Okay, so class test. Okay, so class test, I have a private ID. Okay, so basically the ID is private, you cannot access it, but you can access it. Okay, in the constructor, I can create a new test and take in the ID so ID equal I. Okay, so I see our ID is alive. So when I see set live, it means the constructor has called. Okay, so this is the destructor. Notice the tilde sign, same name. Okay, no inputs. So this is the destructor. Destructor, I just see out our ID has died. Okay, so by looking at the display, we can figure out when is constructor called and when is it not. So let's see here. Okay, main. test B and a pointer P. So here, this is the constructor, right? So 1, 2, 3. Therefore, I see 1, 2, 3 alive. Okay. Pointer P, there's nothing constructed. All you do is that you declare, yes, there's a pointer called P that points to a test. Does it point to a test now? It doesn't. It's just some random number in there. I didn't initialize it to anything. So it's just random number in there. So if true, okay, so why is if true? Basically, I'm going to create a new scope. A new scope, right? So this is the new scope. In here, I create C, which is 456. Okay, so 456 is created, alive. Then I exit the scope. And so inside here scope. When I exit the scope, there's no more C. Okay, we understand there's no more object called C, no more variable called C. So down here, 456 died. Okay, so I exit the scope, destructor is called. Okay, then next one. Here, okay, before I come to here, I call F. Now what's F? Okay, so I go to F. F returns a pointer to a test. Okay, so F says test A 999. So 999 is created. Right, this is created on the stack, right? A is on the stack. Yes, so then here I do a new test. When I say new test, this is created on a heap. Because new. Okay, so when I create on the heap, you'll say 1789 is alive. Okay, my pointer Q, which is on the stack. Okay, so Q is on the stack, points to this test. So Q is on the stack. Okay, points to my test on the heap. Okay, then I print end of F. So end of F print. Then return Q, which is the pointer to my test. Now function quits. Function quits. A goes out of scope. Right? Because A was on the stack. A goes out of scope, so we see 999 died. Okay? 999 died. A went out of scope. So we are here now. Okay. Here I delete P. So what? Okay, before I'm here, this thing returns the Q, right? Returns Q, which is the pointer to a test on the heap. So I assign to P. P is a pointer. So when you return a pointer Q, you're returning the address content. So I'm assigning the address, the content of P to this. Notice there's no start. Content of P. So my P will point to test. Okay, this point of manipulation, you are clear now, right? In a sense, here the Q contains some address 1, 2, 3. So address of my test 1, 2, 3. When I return 1, 2, 3 is being assigned into P. So P, the value 1, 2, 3 is copied. And because they are pointers, they point to the same 1, 2, 3 address. So P is now this. Now I can delete P. P is a pointer. I can delete P. So what happens is I will delete this test. This test was actually 789. So you see, 789 died. Okay. Finally, CL end of main, CL end of main, end of main here. Then end of program. End of program, B goes out of scope. Okay. When B goes out of scope, 1, 2, 3 died. Okay. So here's an example of showing when the object instance is created and when it is destroyed. Okay, both on the stack where your scope matters, or on a heap where you must explicitly new and delete. Okay, so wherever you new, you must delete. You don't forget to delete, then you end up with leaking memory. Okay, in the well, you may ask, then isn't it very troublesome? All right, in modern C++14, there are things like what do you call it? It's not auto pointer. Auto pointer have deprecated. It's not unique pointer. It's a unique pointer. So there are certain more advanced pointer libraries, okay, that will do help you automatically delete the pointers. Okay, once it realizes no one is referring to it. Okay, so there are these new things in C++ 14 and beyond. Okay, so our old Q struct has this big problem. Let us, okay, structs are not nice to procedural are not nice, right? So let's wrap everything up and create our own class Q. Okay, so again, instead of struct, we just use class. Okay. Here I don't put private. So by default, whatever properties or methods that you have is by default private. Okay, opposite from struct. Struct is by default public. Okay. So here I have size, I have head, I have tail. This is also, so this part here, same as the struct Q. Nothing has changed. Yeah. If you don't put private, it is by default private. Okay, so that is what C++ convention, I mean, the language specification is. Okay? I mean, if you put private, it's fine, but normally you don't put private, is by default private. Okay? Here I put public. So once I put public, everything after this is public. So I can put public here, then private again, then public again. I mean, I can mix and match, but again, you go and do that, it's quite confusing. Okay, so here now NQ is a public. So NQ basically, this is the same code, right? I take from the so it's the same code. Nothing is different. Only thing I don't need to use the node.n or whatever. So here I create a new link node n, and I have access head and tail and size directly. I access all this directly. Front will just be the head item. Oops. Okay, and now you dequeue. Okay, when you dequeue, you delete n, right? Okay, now we just add our destructor. So if our queue goes out of scope, we just need to keep deleting queue. Okay, so while the head is not now, means there's still items in the head. I mean, there's still items to dequeue. Then I can just call dequeue lah. Okay, or I just manually do this and delete. I mean, if I call dequeue, I need to check for queue tail or not. But here, I don't want to bother checking for queue tail, yeah, because I just delete. Okay, so get a head and delete. And then reassign a head again and delete, reassign a head again, then delete. Okay. Okay. So this is OP. Let me see. Are we ending soon? I think we're ending soon. Couple more. Where we are. Yeah, a few more slides. Okay, we'll be ending soon. Okay, so OP is a paradigm. Okay, it is not a language in a sense. Okay, it is just a way of organizing information and process. Okay, so the main ideas found in OP, what we've gone through today, is this thing of classes and instances, and attributes and methods. Okay, so a class is a blueprint, it's a template. Okay, it defines the attributes and methods of the class, and it defines the visibility. Okay, typically private attributes, public methods. Of course, there are also private methods you can have. There are also public attributes you can have, lah. Right? So again, you determine your needs and write them accordingly. Then your instances are basically the concrete instantiation, the manifestation coming out, right? The thing become real, okay, of a template. Okay, so just to finish up, okay, I'll show you examples. So this is the OO paradigm. So why we teach you OO in C++ is useful because even other languages, the constructs and the idea is the same. So for example, Java. This is how I write a bank account in Java. You see, I use class. Okay, Java, a little bit different. Every single method or attribute, I must put an accessor here. Okay, so Java has, I think, 4 different accessibility: private, public, protected, and nothing. Okay, so if you don't put anything, it's considered a nothing, a category of its own. So for Java, I need to specify, right? For every property. And so Java also have int and double lah, very close to C++. So here, so you see this is a constructor, right? Exactly the same. Public, no return value, and this. So this same name. So this is a Java constructor. So same thing here. Public void. Java also got void. Transfer from. Okay, notice Java don't need to pass by reference. In a sense, Java can only pass by reference. Okay, so other programming language, there is no option to choose, I pass by value, or I pass by pointer, or I pass by reference. Right? Most programming language have no option for you. Right? Okay, there's a certain default. So things like integer is passed by value. Things like bank account is passed by reference. It's the nature of the language. Okay, so again, can be quite confusing in the sense. So things like, well, how come integer is value? How come this is reference? Just the way it is, the language is written. All right. But most of the time, this is what happens in slightly more modern language. C++, you must give you option to specify, give more control to programmer. Okay, so here, that's why this is by default pass by reference, so that I can just deduct this. Okay, so amount is primitive, so it's passed by value, and this is the rules of Java. But again, you see the code and the syntax looks very similar to what you have learned. So if you're going to Java, in the future modules, it is pretty much similar. Okay. Let's look at Python. Python is another language which I think the data science or the data analytics students will be touching. So Python says here's class bank account. So if you look here, you guess is in it looks like your constructor. Okay, then you have account number and balance. Again, notice one thing odd. Python have no types. In Python, you don't have to specify types. Python dynamic type. Anything goes for a variable. So you don't have to specify. Is this self thing? So here you guess self dot account. So self functions like this, right? This self pointer. This that points to myself. Okay. So again, transfer self and from. So this self appears explicitly here, right? So basically from minus and self balance things. Okay. So again, certain things are passed by for Python, everything is passed by reference. Okay. Amount is passed by reference, but by changing amount, you don't actually change the actual value in the sense. It's a bit different in Python. Okay. So everything is a reference. Even your integers are reference to some space in memory. Okay. So yeah, okay. This Python. Okay, so that is all. Do I have any other okay. That's all for now. Okay, because next week we'll talk about inheritance. Slightly more complex topic. Then the next week after, we say what happens if you inherit, then you customize different behavior. That's called polymorphism. Okay, so in summary, so I think today is a little bit heavy in terms of new paradigm, new syntax. Okay, so someone asked for tips for lecture 7 training. Okay, we can look into that later. It's the lecture 7 Q6.